When people think about advanced technology, they usually assume perfection is the goal. Maximum strength, maximum uptime, maximum efficiency. But many of the most critical systems in the world are designed with the opposite principle in mind. They are designed to fail. This concept is known as failure by design, and it's a core principle in engineering systems where uncontrolled success can be more dangerous than controlled collapse. The idea is simple. When systems operate under extreme stress, something will eventually go wrong. The question isn't if failure happens, it's how it happens. Well-designed systems fail safely. Instead of breaking catastrophically, they shut down specific components, shed load, or trigger protective modes that limit damage. Think of electrical breakers that trip, pressure valves that release, or software systems that intentionally go offline when conditions become unstable. These failures aren't bugs, they're features. In complex environments, systems interact in unpredictable ways. A single overload can cascade through networks, turning a small problem into a massive failure. Failure by design interrupts that chain reaction. By sacrificing part of the system, the whole survives. This principle is used in power grids, aircraft control systems, data centers, financial infrastructure, and military command networks. In each case, engineers intentionally define failure points, places where the system is allowed to break so it doesn't spiral out of control. Redundancy plays a key role. Critical systems are often duplicated or distributed. If one component fails, another takes over. But redundancy alone isn't enough. The system must also know when to stop trying. Pushing beyond safe limits can be worse than shutting down. Modern systems increasingly rely on AI to manage these decisions. Algorithms monitor stress, performance, and risk thresholds in real time. When conditions exceed safe parameters, the system initiates controlled failure faster than humans could react. That speed matters. Human operators often hesitate, hoping a problem will resolve itself. Machines don't hesitate. They follow rules designed to prevent worst-case outcomes, even if that means temporary loss of capability. There's a strategic dimension too. Systems built to fail safely are harder to exploit. Attacks that rely on overload, saturation, or cascading disruption lose effectiveness when systems isolate damage automatically. What looks like a vulnerability becomes resilience. But there's a trade-off. Failure by design can be misunderstood. When systems shut down, people assume weakness or malfunction. In reality, the shutdown may be the system doing exactly what it was designed to do. The danger comes when designers fail to anticipate real-world complexity. Poorly chosen failure points can create blind spots or unintended dependencies. That's why testing and simulation are critical. Failure must be rehearsed. In the future, as systems grow more autonomous and interconnected, failure by design becomes even more important. Perfect systems don't exist. Survivable systems do. The strongest systems aren't the ones that never fail. They're the ones that fail on their own terms.